You scan across all wavelengths to prevent using a wavelength that would cause photodegradation, and to find the lambda max, which is the wavelength where the maximum absorption occurs. This is necessary to minimize deviation from Beer's law. Once the lambda max is found, we can find the absorbance at that wavelength for all concentrations. In this lab, we created 3 dilutions by adding water to the stock solution, creating a meniscus in the volumetric flask. Then, we transferred our dilutions into cuvettes using a transfer pipette. In the spectrophotometer room, we found the lambda max, which was 611, and zeroed it with a cuvette filled with water. After zeroing it, we inserted our first dilution and scanned for absorption, and repeated this process with all dilutions. The Beer-Lambert law states that the amount of energy absorbed by a solution is proportional to the solution's molar absorptivity and the concentration of solute. Therefore, the more concentrated solution absorbs more light than the diluted solution. Failing to zero the spectrophotometer will cause our absorbance values to be higher than they actually are. Here are the concentrations that we had calculated. Here are the absorbance values we calculated along with the lambda max. And here is us cleaning up our station once we're done in the spectrophotometer room. And that's how you perform the copper amine synthesis lab.